Wayne County Public Library. Today, Miss Leanne is with me, and we're going to talk about growing a beanstalk, okay? Because we did read a book on Jack and the Beanstalk, a little fractured fairy tale. So growing a beanstalk, all you're going to need for this stem exercise is a mason jar, some cotton balls, and any kind of bean that you want. Okay, so what you're going to do to start is Miss Leanne made this one up. She took the mason jar, placed cotton balls in there, and put a bean down in there. Now there are some tips we're going to give you about doing this. First of all, any kind of bean will work, and you want to soak the bean for 12 hours before you start this. Okay, no more than 24, but at least 12. And you're going to put the bean near the top so it doesn't struggle to grow, because that's a very tender little shoot, and you don't want to cover the bean with cotton just yet. You want to leave the side open so a tender shoot can grow. And your bean's going to need about 8 to 10 hours of sunlight per day, and please don't let the cotton dry out. You need to keep it moist. And Leanne's going to show you just about how much water you're going to need to keep putting in there. About every other day would be good. And eventually you're going to see a good root system. That's going to be about 2 weeks. And by that time, you should be able to transfer it. This beanstalk we've had growing now for 7 days. We've had this one for a week, and you can see how much it's already grown. I think we had a shoot after, what, 3 days? Yep. That was kind of cool. And you can barely see it, but there is a root system in the bottom. That's why we put it in a glass jar, so you can see the root system. Okay, and you're not going to have a gigantic stalk like Jack did, but you're going to have a nice, healthy little bean. So why did that bean sprout, I wonder? It's just actually water and sunshine. That's all there is to it. And why cotton? Well, you don't actually need cotton. You can also use paper towels. But the idea is to have something absorbent to hold the water so the bean will stay watered. Okay, and the beans can grow in the fibers of the cotton because the cotton attracts and holds water, and that also gives the plant plenty of space to breathe and the air to penetrate in there. So the seeds don't grow because the cotton has minerals or nutrients at all that are required by the plant, but when your plant gets bigger, you're going to need to put it in the soil, which does have the minerals and nutrients that it's going to need to get bigger. Maybe not quite as big as that beanstalk Jack climbed, but it will get nice and big. Okay? I hope you learned something about growing a bean, and everybody give that a try. It's really kind of fun. Thank you. We're going to show you a little STEM activity that you guys can do with another craft that you're going to make when you get your SRP packet from us. Okay, so what we have is actually a maze, and on top of this maze, as you can see, we put wax paper. So we're going to find out, why does water bead up on wax paper? And would it work on a plain sheet of paper? What if you use something besides water? So Miss Leanne is going to do some testing, but what this is simply called attraction. Water molecules are attracted in every direction by other water molecules and are more attracted to each other than they are the wax paper, as you can see it beading up there. And your goal is to try and get that, stay in that maze and try to get that bead of water all the way to the very end. Now, since they're attracted more in uniform or consistent direction, they're going to form a more stable arrangement at the surface, and this is called surface tension. That's why it's beading up together. They're all like a magnet holding on to each other. And water's attraction to itself and its strong surface tension causes the water to bead up. That's why it doesn't spread out on that wax paper. So water molecules are actually made up of 2 hydrogen atoms and 1 oxygen atom. So what we're going to do, and actually, did you know that water is a chemical? I learn something new every day. And the chemical formula is called, everybody should know this, H2O. Okay, so we're going to find out what happens if you put alcohol on the wax paper. Let's see what see, it's not beading up. So both the alcohol, and then let's try also, let's clean that one off, and we're going to try another solution. We're going to try a detergent mixed with water solution. Let's see if this beads up. Not very well. Let's see if you can roll that down along the maze. No, not really. Kind of going a bit slow. It's starting to thin out a little bit. So both the alcohol and detergent molecules have parts that are attracted to the water, and as you can see, the detergent has actually left a trail along in the wax paper. It didn't bead up like the water did. It's kind of spreading itself thin as it goes, so it would probably dry out about to here. So, but both have also parts that are made up of carbon and hydrogen atoms, and they bond together, and they're not particularly attracted to water. So that's what happens. These parts interfere with the interactions of the water that the water molecules have for each other. So this disrupts the water's surface tension. You remember we talked about that a little bit earlier, and that's why it doesn't bead up on the wax paper. And by the way, did you know that water is the most abundant molecule on Earth? Approximately 70% of the Earth's surface is water. Learn something new every day. Water is the only substance on Earth which naturally occurs in a solid, liquid, and gas form. So I hope you had fun learning a little bit about water today. Hello everyone, I'm Lisa Stevens and I'm with the Wayne County Public Library. Today I have with me Miss Leanne.
Hi.
And we are going to drop Humpty Dumpty. In your SRP packet that you get, you're going to have a little idea of how to do this. It has instructions on dropping Humpty Dumpty. The first thing I'm going to tell you though is you're going to want to do this with hard-boiled eggs so your mom doesn't get mad at you. And plus you can have egg salad when you're done. So let's talk about dropping Humpty Dumpty. As you can see, we have 4 different kinds of material in our bags that we actually have eggs in. Miss Leanne can show you where the egg is in the rice. Trust me, it's in there. Now, the idea behind this STEM exercise is to explore gravity, force, and acceleration. We experimented yesterday and we had 2 surprising results. Now, when we did it, we kept our height at 6 feet when we dropped each bag. Today, we're just going to drop it on the table because I think it'll still make the same effect. Okay. The tissue paper one we found out, it only took 1 second to drop and it broke. That was a surprise to us because we thought maybe, you know, tissue paper would make it last a little bit longer, but it didn't. So I think we've got it wrapped a little bit better in tissue paper. We also did one with bubble wrap, and as you guys know, it probably did not break. It did not. It took just 0.93 of a second, and it didn't break. The rice, this was a surprise. It only took 0.90 of a second, and it did not break. I thought it would because the rice is kind of hard, but the rice absorbed most of the shock from when it hit the ground. And the plain one, well, we're going to let you guys see the results of that one. The one we did the other day only took 0.96 of a second to fall to the ground. So why? I'm not going to get into a lot, but it has to do with Newton's law of motion. And the first law is an object at rest will stay at rest, and an object in motion will stay in motion unless acted upon by an external unbalanced force. And here the unbalanced force is gravity. So we're going to let Miss Leanne start with the first one. It is the rice, and we're just going to drop it from, I don't know, a height of about 3 feet down onto the table. Okay. Now, what you just experienced there, boys and girls, was gravity. And look, the egg did not break. It is still whole. Okay, so that unbalanced force that Miss Leanne just showed you was gravity. Newton's second law deals with the relationship between an object's mass, its acceleration, and amount of force that it exerts. The heavier an object is, and the faster it travels, the more force it exerts. So that's what we saw with the rice. The rice was the heaviest object on this table, and it fell the fastest. So we're going to reduce the mass of the eggs bag, and we're going to reduce the amount of force it exerts as it falls. So now we're going to try the bubble wrap. And we're pretty sure this one's going to be safe. And go. I don't know, that was an awful loud thud. So Newton's third law states that for every action there's an equal and opposite reaction. And that means when you exert force on an object, the object exerts force back on you. This helps to understand why the egg breaks when it hits the ground, and it did. You would think the bubble wrap would be safe, but it wasn't. So the ground is returning force, or as we can see here, the table is returning the force from the egg as it meets the ground. So the shock-absorbing materials can help reduce the amount of force exchange between the ground and the egg. bubble wrap was not one of those. So let's try the tissue paper. We're going to try and drop it again from the tissue paper and go. I think that one broke too. Let's see. This is amazing because when we did this at the height of 6 feet in the same thing, yep, it sure did. None of our eggs broke. I hope you guys have better luck than we did with ours. So actually it looks like rice is the best thing. And of course we know what's going to happen to this last one, but let's do it anyway just for fun. Again, dropping from 3 feet and smash. That was the worst. Poor Humpty Dumpty. So boys and girls, don't put your mama's eggs in plastic bags and start dropping them on the ground. As I said, try this with hard-boiled eggs and the shell will stay intact or cracked, and no matter what, you can make egg salad. We hope you enjoy, well, I hate to say it, but watching Humpty Dumpty fall. We're going to see if we can find a few kings, horses, and men, and we can put Humpty Dumpty back together again. Hope you guys enjoy this, and we'll see you next time. Thanks. Bye.